Are you fatigued, struggling with energy levels, drinking too much coffee, wake up feeling tired? Well, today we're going to talk about the organic acids test. It's the first part in our series discussing energy production. The organic acids test, which has become my favorite test, really allows us to look at the whole body. It allows us to look at energy production, which we'll talk about today, mitochondrial function, detoxification, GI dysbiosis, neurotransmitter issues, vitamin and amino acid status. So when we look at the organic acids, what we're measuring is how molecule A uses enzyme AB to go to molecule B. And this requires different nutrients or cofactors and minerals. And if this is deficient, molecule A will build up and spill over into the urine, and that's basically what we measure. So if molecule A is trying to go to molecule B and there's not enough nutrient to allow that to happen, molecule A will build up and eventually spill into the urine, and that is what we measure in organic acids. The majority of our patients have energy production issues. So energy is created when we eat protein, carbohydrates, and fats, and it's converted to acetyl-CoA and eventually goes down to the Krebs cycle where it makes energy. If we have problems with this macronutrient conversion to energy, some of our symptoms are going to include fatigue, weight gain, and insulin resistance. This is a sample of the Krebs cycle and how we utilize our carbohydrates, fats, and proteins to be converted to the acetyl-CoA and then eventually transferred down to the citric acid cycle to produce the 36 molecules of ATP, or our energy. So if there's a breakdown of carbohydrate metabolism or protein or fats converting to acetyl-CoA, our body's going to have a hard time converting energy, and we're going to notice that downstream in the Krebs cycle. So when we convert energy from carbohydrates, glucose from food gets converted to pyruvate. When it enters the Krebs cycle, it ultimately, through a process called cellular respiration, it yields the 36 molecules of ATP. It requires certain vitamins like B1, B2, B3, and B5, and lipoic acid to break down the pyruvate. If we see on the organic acids tests, there's elevation of certain markers like pyruvate or alpha ketoglutarate. We know those keto acids are sharing the same cofactor, so this individual would be deficient in CoQ10 or some of the B complex vitamins. Up above, it's a marker of some of our B vitamin markers like keto isovalerate, keto isocaparate, and keto beta methylvalerate. So in this situation, we would want to supplement with a good B complex like B1, B2, B3, and B5, and lipoic acid. Here are some B vitamin marker summary. So if pyruvate is the issue, B1 and B5 is the vitamins of choice. If alpha ketoglutarate, alpha keto isovalerate, alpha keto isocaparate, and alpha keto beta methylvalerate are an issue, you would want to supplement with B1, B2, B3, B5, and lipoic acid. Xanthorite is a great marker of B6, beta-hydroxy isovalerate for biotin, methylmalonate for B12, and foraminoglutamate or FIGLU for folate. We utilize the methylmalonate test quite frequently because it is a marker for B12 absorption. So as certain amino acids like isoleucine and valine and the odd number of fatty acids like the 3s and the 9s use methylmalonate to absorb and convert to B12 to eventually produce energy. If the cofactor of B12 isn't there, the methylmalonate is going to be excreted into the urine, and this is a good B12 deficiency marker. We use this a lot for our methylation status, so we can evaluate the B12, and the next test will show you how we evaluate folate. So with folate, the marker is foraminoglutamic acid, more commonly known as FIGLU. So when FIGLU is present in the urine, what it is showing is a folate deficiency. So B12 and folate are super important in the whole methylation process, especially when it comes to MTHFR and MTRR and the recycling of the B12 and the folate. We also can look at lactate as a marker. So pyruvate can be converted to lactate, and it is an anaerobic metabolism. And this in part is a normal function in skeletal muscle, but it also can be high due to high alcohol intake, too many pharmaceutical drugs, hypoxia or lack of oxygen, and metabolic syndrome. So if you have high levels of lactate, what we want to do is supplement with CoQ10, lipoic acid, and B1. So here's an example of both pyruvate and lactate being high. So in this situation, lipoic acid and CoQ10, you would want to supplement with to restore the carbohydrate metabolism. At times, and especially these days, a lot of people are on a high protein, low carb, like an Atkins type diet. This will produce ketones in the body. Now, if the person is not on a ketone diet and they have a high beta hydroxybutyrate, this is a good marker for metabolic syndrome or insulin resistance. Our body really prefers using sugar to make energy, but will begin to make ketones from fatty acids when necessary. So again, this is the chart looking at the carbohydrates, how it gets converted to pyruvate acid over to lactic acid, how the proteins to the amino acids go to the acetyl-CoA, and how the fats get converted to the acetyl-CoA. We're going to talk about the fat metabolism here in a second. So when we're talking about energy from fatty acid, it really requires two supplements to allow it to cross the mitochondrial membrane. The first one is carnitine, the second one is B2. So if on the organic acid markers, we see an elevation of adipate, subrate, or ethyl malonate, this signifies a deficiency of carnitine and or B2. So some of the results of poor fat metabolism are fatigue, inability to lose weight, insulin resistance, and metabolic syndrome. On the test, this is what it looks like. These are the markers that I mentioned, adipate, subrate, and ethyl malonate. And in this situation, carnitine and B2 would be provided for the supplementation to restore the fatty acid metabolism. This is a slide showing how when we take the food and we convert it to acetyl-CoA and it enters the citric acid cycle, there are many different components of this cycle that need to be addressed. And so we have like citrate and cis-aconitate and isocitrate, alpha-ketoglutarate, succinate, fumarate, malate. Now, if any of these are off, you're going to have energy production problems. So the whole cycle needs to be looked at, just not how we're converting food, but once we are converting the food, how it is works its way down the whole Krebs cycle so we can produce that 36 molecules of ATP. If we see all the energy production citric acid cycle markers elevated, this signifies a severe CoQ10 deficiency. This individual will have virtually no energy, and the mitochondria needs to be restored, and beginning with CoQ10 and restoring the energy is a good place to start. So this is a case study. I had a distance patient. She was a 53-year-old female. She had chronic fatigue since her early 20s. What we did after a thorough consultation and reviewing her basic complete metabolic panel and CBC is we had her order a couple tests. We had her order the organic acids and the genetic testing from 23andMe. This is what the organic acids test looked like. So her carbohydrate metabolism was having a lot of difficulty, and you can see a lot of markers in the citric acid cycle. was having issues, and we are getting really close to having issues with fatty acid metabolism also. So this person really has had no energy for years, has been to numerous doctors throughout the country trying to find solutions, but never had run this test. And here it was for me, black and white, plain as day. We also ran the genetic test, and what we found is numerous SNPs of major markers. So the BHMT, O2 and O8 were an issue, CBS, COMT V158, the DAO for histamine breakdown, FUT2 for probiotics, the GAD enzymes were all high, and then she was heterozygous for MTHFR A1298C and C677T. So there were a lot of things going on with this patient, and when I looked at her, I was thinking, okay, so where do we start? She has multiple issues. We have genetic issues, inability to break down nutrients. And what I've learned through the years is you have to begin slow. If you provide too many supplements, the body can't handle it. It's going to break down. The patient's not going to follow through, and they're never going to restore the energy. So we started to begin kind of a macronutrient approach to allow her body first to be able to break down the carbohydrates, fats, and amino acids. So we began some free-form amino acids, carnitine, vitamin B2, and CoQ10. We were estimating about 3 months of macronutrients, but after 1 month, the fatigue already had improved. And now, once it began to improve, we slowly started to address the micronutrient and methylation status. But if I would have done that in the beginning, this individual would have crashed and burned and never would have recovered. So what you have to do is first build up the ability to convert energy, allow the cycle to work so it can produce the 36 molecules of ATP. Otherwise, it diverts into a cycle called the Cori cycle, where the body actually loses 6 to 8 molecules of ATP. So we'd rather gain it than lose it. So we're going to be retesting this patient in about a month to see where her markers are. But symptomatically, I already know they've improved, and so does she, because she has energy levels that are sustaining throughout the day just after probably 6-8 weeks of treatment. If you have any questions, you can go to our website, drmichaelveselak.com. We have a lot of information on there. If you're interested in a consultation, you can call our office, 805-482-0723. We do a lot of distance patients, actually nationally and internationally. So if you have had some tests, you want me to review them, or if you're considering maybe getting some, you're not quite sure, we can talk about if we think they're necessary. And you can always email me at dr.veselak, Veselak,